Hi everyone. We have the next talk from 3:15 to 3:45 and followed by a break. So with that, we have Python and SQL better together, powered by DuckDB by Alex. Please give a round of applause. Yeah. So he'll take questions at the end. There are two mics over there if you want to stand over there and ask questions, or even after the talk is over, the speaker would be here for a while. So with that, over to you, Alex. Thank you.
Thank you so much. Well, welcome everybody. Really appreciate you coming here to my talk. I'm talking about Python and SQL, moving beyond the language wars and working better together, powered by DuckDB. First, I'll say howdy. Howdy, I'm Alex. My background is industrial and systems engineering from Virginia Tech, and then I spent 9 years at Intel breaking into the data world, ending up as a data scientist. In 2020, I discovered DuckDB. I was helping build a self-service analytics platform at Intel, of course, powered by Python, and a fortuitous Google search brought me to DuckDB, and it handled every crazy SQL query I could throw at it, and from then on, I was a huge fan. So I became a big Twitter fan, and then I was actually recruited based on that and a blog to do some part-time documentation and blogging work for DuckDB Labs. So who is DuckDB Labs? DuckDB Labs is founded by the creators of DuckDB, Hannes Mühlhausen and Mark Rosfeld, and they're a custom support and services organization based mostly in the Netherlands, of database experts. So if you're excited about DuckDB after today, you want to integrate it into your custom product or into your enterprise, they're the perfect folks. And then in 2023, I decided to make the jump and do all DuckDB all the time. So I joined a company called MotherDuck. And MotherDuck is building a cloud service based on DuckDB. And it's going to be a serverless platform, so we're really excited about a serverless DuckDB platform in general. It's a really fantastic engine. But part of our secret sauce is whenever you connect to MotherDuck, one SQL query will run partially in the cloud and partially on your laptop. And we think that's really disruptive in a couple ways. You know, if it's on your laptop, you've already paid for your laptop. Every CPU cycle there is essentially free. And there's no network lag, no network latency. It's 0 milliseconds away from you. So interactive analytics like slicing and dicing, filtering, drill down, those become interactive speed. So we're very excited about that. However, today, I'm here on behalf of DuckDB Labs, and we're talking all about the open source project, DuckDB, which I'm very excited about. So first, what inspired Hannes and Mark to create DuckDB? What's its reason for being? What if I told you there was something wrong with the data world? Like a splinter in your mind driving you mad. Do you know what I'm talking about? Well, as soon as a problem gets a little bit too big for pandas, you have to throw a giant distributed system at it. It's like cracking a nut with a sledgehammer. It's not ergonomic. Hannes has mentioned another saying in German is to shoot at sparrows with cannons. And I really love that visual. DuckDB is designed to scale up as far as possible to delay having to use the distributed system as long as possible. It really simplifies things. Another part of the DuckDB origin story is Hannes and Mark reaching out to the data science community. And so they said, hey, we're database people. You're data science people. What kind of databases do you guys use? And the data science folks said, well, we don't really use a lot of databases. We've embedded these things called dataframes, and we really love them, and they're really great for all these reasons. Hannes and Mark said, okay, that's very interesting. Let's collaborate. So let's look at a typical data science workflow, and let's think about where does the database fit? So I start with a hypothesis, and then I'm going to pull some data. Maybe that's in a database, but maybe it's an API. Maybe it's a flat file. Maybe it's a hierarchy of Parquet files on an object store. Maybe there is no database there. And then I'm going to explore that data. Maybe I'll explore it in the database, or maybe I'll just grab it all out of the database and I'll explore it locally. Am I really going to take a flat file and upload it to my database just to explore it? Probably not. Maybe there is no database there either. And then I'm going to do some modeling. I want to do some forecasting. I want to do some machine learning. That's almost certainly in Python or R. No database there. And then I'm going to visualize it. And when's the last time you used a database to build a chart? Never, right? So where is the database? Well, DuckDB is the database that's designed to fit seamlessly within this existing workflow that you have. So you can go back and forth from your Python workflow to your database seamlessly all throughout. So you can go through this as fast as possible. So what is DuckDB? DuckDB is an analytical relational SQL database. And it runs in process. The most famous in-process database is SQLite, so we've nicknamed ourselves the SQLite for analytics. It's MIT licensed, so you can use it for anything you'd like, commercial or not, and we've got clients in over 15 different languages. However, our most popular one is in Python. We've got over 2 million downloads every month. DuckDB was created back in 2018, and it's built in C++. So those are all the fast facts, but what do I want you to remember after today about DuckDB? First of all, it's fast. It has to be. It's table stakes. Otherwise I wouldn't be here, you wouldn't be here, right? DuckDB is going to use all your cores, it's vectorized, and it also takes advantage of modern CPU cache hierarchies to be incredibly fast. But that's also not enough. It's also got to be easy. By being in process, there's no server to manage with DuckDB. So you don't have to take a couple weeks to set up and properly configure a cluster. You don't have to have a team to do ongoing maintenance for it. It's simple. You only run it when you need it. Another thing is DuckDB is there's a common misperception that it's an in-memory database, but it's actually an in-process database. So just like your Python process can read and write to disk, so can DuckDB. It also has a persistent file format. And what that means is you're no longer limited to your 16 gigs of RAM for your size of problem. Suddenly you can start to solve 2 terabyte problems with just your laptop and DuckDB. So 2 orders of magnitude bigger problems that you can solve if DuckDB is in your toolbox. And here's where I want you to get creative. DuckDB can fit anywhere. We'll see how we can read and write data frames, and really it can fit in a large variety of Python workflows. It can even run in WebAssembly to run in your web browser, both by itself and also through Pyodide, which is underneath PyScript. Another way to think about DuckDB is to compare and contrast it and to divide up databases in a couple of different categories. So the first category is on our x-axis, transactional versus analytical. So with transactional, think about tons of tiny operations happening concurrently. So you've got a shopping cart, people are adding or removing items thousands of times per second. And then an analytical workload is much more about looking at trends. You're going to look at many, many more rows of data, but less frequent with less concurrency. It's all about maybe analyzing your sales trends, what products are most popular, where should I spend my marketing dollars. On the y-axis, another way to subdivide databases are client-server and in-process. And client-server databases are typically what you think of when you think of a database. It's running in a separate process, typically on a separate physical server somewhere, and you're going to send a message. Typically that's SQL. It's going to crunch away and then send you back an answer. The challenge there is when it sends you that answer back, it's sending it to you over a very thin pipe over the network. So it's not great for large result sets. It's also using decades-old protocols for doing that. And they're frequently 10 to 100 times slower than just sending a CSV file over the network. So it tends to be very difficult to work with large data sets in that model. In contrast, we have SQLite. SQLite runs in process, shares the same memory space as your Python interpreter. And SQLite is actually the most popular database on Earth. There are over 1 trillion active SQLite databases. It runs in every phone, every laptop, every operating system, even in aircraft. It's everywhere. However, there's one metric it doesn't lead in. That's how many islands does your CEO own? There are other databases that lead in that metric, but we're big fans of SQLite. We've taken a lot of inspiration from it. So you've noticed there's a blank spot. Of course, that's intentional. We do think that data scientists and data engineers really lived in that blank spot for a long time. You're working in another language, typically in Python, and you're doing work on a large amount of data of an analytical nature, but there wasn't really a database designed for that workload, and we think that's really where DuckDB can fit. So let's talk now about how we can get Python and SQL to work better together. We've got a couple different ways. The first is through DuckDB's SQL dialect. It's actually in many ways inspired by Python. So we'll see ways that we've really modernized the SQL experience, so if you're going to write SQL, it should feel a lot more like Python. You can also seamlessly read and write data frames with DuckDB. And because you're in that same process, in the same memory space, this is really fast. You don't have to send it over a socket. It's all just trading pointers in the same memory space. We also have learned a lot from data frames. Our architecture is really designed to combine the best of both, data frames and databases. And finally, you can even use Pythonic APIs, data frame APIs, right on top of the DuckDB engine seamlessly. You don't even have to know it's there. You get all the benefits of this world-class engine while getting to use syntax that you love. Let's look first at a Hello World example. What does it look like to do a Hello World SQL example in DuckDB? So typically, you'd start with your pip install, and it would download that precompiled binary, 20 megabytes, no dependencies. But here's a screenshot of Google Colab. It's actually pre-installed in every Google Colab instance today, so we can skip that. So we'll import DuckDB, and we'll do duckdb.sql, and then a string for our SQL statement, select 42, and we'll do .fetchAll, so we're compliant with the Python database API spec. And so we get back a list of tuples with 42, the answer to life, the universe, and everything. So it's just one line of code to start writing arbitrary SQL statements with DuckDB. So let's talk a bit about more advanced SQL with DuckDB. This is a long list. I won't cover all of these. But really, our goal is to be very closely aligned to Postgres at a foundational level. So we actually began with a fork of the Postgres parser before we improved it. So it's highly Postgres compatible if you like Postgres syntax. But we've pushed the limits in two key ways. One, we want to simplify SQL. We want to make it easier and faster to write and less error prone. And secondly, we want to supercharge it. We want to take it to places where typically only imperative languages or data frames could really go. My favorite of all of these is group by all. So instead of specifying columns in your group by clause, you can just put the keyword all, and DuckDB just figures it out for you. It's how it should have always been. Why do I need a group by clause? I don't. Group by all, never worry about it ever again. Everything in bold here is actually Python inspired. So you can have trailing commas. You could do string slicing with brackets. You could even do full list comprehensions in your SQL statement. So in a lot of ways, we're taking inspiration from Python's modern syntax and how ergonomic it is. How about reading and writing data frames? Let's go back to our hello world example at the top, and we'll add a hello pandas example. So we'd pip install pandas, import it, and create an example data frame, mydf. And then I'd just say duckdb.sql, select star from mydf. Well, what's happening there? All I did was put in a string. Well, first thing we'll do is check, is there a table named mydf in my DuckDB database? Okay, there isn't. All right, let me go look in my Python local variables. Let me find that variable named mydf. And let's check the class. Is it a class I know how to read? Is it pandas? Is it Apache Arrow? Is it Polars? If it's any of those, I can read it right where it sits. No copying first, because I natively speak that exact syntax, those C++-based libraries or Rust-based libraries. And then, if I want to get back to a data frame after that, I just put .df right at the end, and I'm right back in pandas. And we have an equivalent .arrow or .pl for polars as well. So in one line of code, we're from data frame to SQL and back. So this could fit in a lot of workflows. How has the DuckDB architecture learned from data frames? We're going to compare 4 different types of things: data frames, client-server databases, SQLite, and DuckDB. And our goal is to be really the best of the combination. So there's many different ways to have fast analytical queries. However, SQLite struggles here. It's fundamentally a row store, and it processes things one row at a time. It's just not designed for analytics. It's excellent at transactions, but it wasn't designed for analytical workloads. Ease of use is a bit in the eye of the beholder. You'll see we've given full marks to both data frames and SQL here. However, we can all agree that managing infrastructure is harder than not managing infrastructure. And that's why client-server databases are harder. Fast data transfer is really a secret weapon of being in the same process as Python. SQLite is an in-process database, but you do have to convert into the SQLite format before you can start operating on your data. Whereas with DuckDB, you can read it right where it sits. Data science integrations are key. How many machine learning functions accept a Postgres database as input? How about a NumPy array or a Pandas data frame? Many of them. So really, it's very important to integrate with the ecosystem. Another very key aspect from data frames is they maintain the original order of the data as you work with it. And we've tried to come halfway here with DuckDB. The traditional SQL relational model is very concrete and says everything is unordered. We don't believe in order unless you tell us an order by. But in DuckDB, we're meeting in the middle. If you're doing a simple query like select from where or an insert, we'll maintain that order for you, so it's much more easier to keep track. The relational API, the data frame API, however, has great value. I'm admittedly a big SQL fan, but I've used pandas, and there's cases where it's just flat out easier than SQL. So what if one tool could work for both? SQL support is also important. There's many people at my company and yours that know and work and live and breathe in SQL. So we can work with them as well. Query optimization is an area where traditionally data frames really struggle. Eager evaluation means you can't optimize across multiple operations. Newer libraries like Polars have made great improvements here. This is really, though, the home turf of database research, and they've had a few decade head start. When's the last time you persisted a data frame? Did you pickle it? Did you save it as a CSV? Or maybe a Parquet file? Or maybe a hierarchy of 1,000 Parquet files? It's a choose-your-own adventure. With a database, you get a predefined storage format that's designed to work well with analytical operations. Large-than-RAM execution is also an area where traditionally data frames really struggled. There's been some process recently. But a quick show of hands. How many of you have crashed your Python process out of memory with pandas? We've all been there. So you're in the right place. Thank you for being here. So Alex, what's the catch? Why isn't every database in process? Well, if you're inside of one process, it's a lot harder to have concurrency across multiple processes. So with DuckDB, you can either have one read-write process or multiple read-only processes. But I have an asterisk here with our no. And here, I'll mention MotherDuck. We're trying to make DuckDB into a multiplayer experience as we bring it to the cloud. So how about writing data frame syntax on top of the DuckDB engine? We've got 4 different ways of doing this. The first way is a fairly traditional database, kind of database-y way, which is user-defined functions. And there's certainly flaws in user-defined functions in general, but there's a few ways where DuckDB pushes this to the next level we think makes it a lot more usable. Also, whenever you import DuckDB, in that same Python library, we have a full relational API, where you can actually do data frame style syntax with the same engine underneath, and we'll see a code example. We also can use the Ibis library, which is a portable data frame API. So you can write the same data frame syntax and run it on 20 different database backends. And DuckDB is actually their default backend now. So whenever you start using Ibis, you started using DuckDB. DuckDB also has an experimental PySpark-compatible API. So you can write the same syntax you would with PySpark, just with a different import statement, and it'll run on DuckDB instead of a Spark cluster. So let's look at a couple of code examples. Here, we're doing some user-defined functions. We'll go ahead and import DuckDB, import some types, varchar, integer, so we can specify those without quotes. And we'll import PyArrow. So PyArrow is the industry standard data translation format. It also has compute kernels, which is this PyArrow compute library. And we're going to define a function using that PyArrow compute library. And we're going to swap our case. To use that function, we'll connect to DuckDB, we'll create a function, we'll tell which input parameter and output parameter types we're using, and we'll say it's an arrow type function. And then we can use that anywhere in our SQL statement. Select swap case, instead of duck, duck, goose, we get duck, duck, goose, how it should be. And then we'll do fetch all. So what do we like about this approach? What makes this different than the UDS we've had for many years? Well, since we're in process, there's no copying of data. You don't have to serialize it anywhere. It's already right there. And since we're using Apache Arrow, both our Python function and DuckDB can talk in the same format. And it looks like swap case is only processing one X at a time, but that X is actually a vector of 2,048 rows at once. So it dramatically reduces the overhead to do them in large batches. So how about the relational API? Another way. Here we're going to have an example CSV file, and we're going to use our relational API to read it. So it's designed to look a lot like the pandas read CSV, and we get back a relation. And that relation object has several different methods on it, so we can project to pick our columns, we can then filter for a where clause, aggregate for grouping, etc. And then when we're done, it'll go ahead and run through the DuckDB engine. And here we get our list of jokes from worst to best. So what do you call a duck burglar? Well, a robber ducky, of course. I will not torture you with the rest, because they're even worse. So what do we like about our relational API? Well, it's composable. If you're working a lot with SQL, usually you have to work with it in huge chunks. It's difficult to break it down. Here, you can inspect your intermediate results, so you can check your calculation along the way. However, we're not giving up our query optimization. We're able to use that same benefit of SQL, where SQL will take care of the order of operations for you to run as fast as possible. Let's take a look at an Ibis example. Here, we'll go ahead and pip install Ibis, and we'll bring in our example data set. Here it's penguins. We love all kinds of birds here. And let's look at working with DuckDB with it. So we'll go ahead and connect to a persistent DuckDB file, penguins.duckdb, and we can send that Ibis table into that persistent database. Then we can pull it back out again, we can work with it, we can do our groupings, our aggregates, same as before. And then when we're done, we can also then push it back to DuckDB to persist it, if we like. So what do we love about Ibis? Well, Ibis is a very full-featured API. It's been around for many years. It's got a lot of work where you can really handle a large variety of syntax. But it's unified. You can think of this as kind of the Pandas API 2.0 to a certain extent, right? Where they had a second try to define that API kind of, once and for all. But it's also portable. You can write that same syntax and swap out your database backend. So if you're using Ibis on another platform, it's very easy to try out DuckDB. And there's also a .SQL method in Ibis. So you can mix and match SQL to your heart's content back and forth throughout your workflows. So once again, better together. Our PySpark API is also something we're very excited about. Of course, this is what you get if you put Duck and Spark into AI. Pretty fun. So here we're going to create our Spark session. In this case, it's not actually going to be Spark, although the variable is named, interestingly, named Spark. And then we're going to create a data frame from Pandas and do Spark operations on it. Grouping sums, same as before. What do we love about PySpark? Well, the compatibility is huge. A lot of people get a lot of value out of PySpark. Let's meet them where they are. However, when you connect to this, there's no cluster you have to manage, and your DuckDB is going to spin up instantly in milliseconds. So this is excellent, especially for testing, for local development, really quite a lot faster for medium-sized data problems. And this API is written in Python. It's a wrapper around the relational API that we saw earlier. So if you're excited about DuckDB and you're a Pythonista, this is a great way we would love to collaborate. So we made it this far, but why is it called DuckDB? Well, ducks are the envy of the animal kingdom. They can fly, they can walk, they can swim. But that's not why it's called DuckDB. Meet Wilbur. This is Hannes Muehlheisen with his pet duck Wilbur. He lives on a houseboat in the canals of Amsterdam. And in that area, ducks make an excellent pet. Unfortunately, Wilbur is now in the duck pond in the sky, but we remember him fondly as the namesake of our database. So we talked about it being fast. Let's look at a couple numbers for performance. And of course, up front, we'll admit, benchmarking is really hard. Hannes and Mark actually wrote an entire paper about how benchmarking database systems in particular is very, very difficult to do well. So please do your own benchmarking. One nice thing about this benchmark is that it was not created by DuckDB. It was created by H2O.ai several years ago to compare libraries across languages. So this benchmark, we're running 5 queries on 50 gigabytes of data, which is 1 billion rows. And DuckDB can complete 5 queries on 1 billion rows in 24 seconds, the fastest of all. That's 10 times faster than Spark, 30 times faster than Pandas. This is on a pretty beefy machine, so this is kind of workstation level performance, and it's still a solid amount of data. But the story gets even better for DuckDB if we move to more advanced calculations. The harder the calculations, really, the better DuckDB is going to perform relative to others. Now, many libraries can't even finish this task, these more complicated queries, and DuckDB's lead stretches further. Let's look at some joins. So in this, you can see very few libraries are finishing this as well. One of these queries is actually joining 1 billion rows to 1 billion rows. That's pretty tough, even on this really beefy machine. We want to give credit to the in-memory data sets from the Julia folks. They're in first place. That's the fun of benchmarks. However, it's a little bit in the name. If you think your data would be larger than memory, in-memory data sets might not be the perfect fit. So let's go ahead and look at the same join benchmark, but with a smaller data set, so the rest of the libraries can finish and we can compare across them. And in this smaller data set, DuckDB once again leads the pack. In addition to raw speed, it's very important that DuckDB can handle the problems that you have in your real-life workload. And that means handling analyses that are larger than memory. So all of our operators support this now. Joins, group bys, sorting, and window functions. But we don't want this to be where as soon as you get close to running out of memory, things get really, really slow, where we restart with a disk-based algorithm and it becomes a performance cliff. We want to gracefully degrade. So in this example, you can see this is a TPCH scale factor 100. So this is 600 million rows, somewhere around, let's see, I think 60 gigs of data or so. And we're bringing the memory limit down from 30 gigs down to 2. So 1/15 of the memory, but performance is less than 2x slower. So really taking full advantage of your hard drive and not slowing down much at all. So we take our inspiration from Galaxy Quest, never give up, never surrender. We're big Python fans in DuckDB, if you can't tell already. So let's see how we work with the ecosystem. We work across all major operating systems and all major CPU architectures and all combinations of those, and we precompile them in CI, so that way when you pip install DuckDB, it's already precompiled in almost all cases. And DuckDB can really run everywhere. We've got a command line tool that you can use to have fast SQL on any terminal. And we also have clients in Python, Node, JDBC, ODBC. ADBC is Arrow database connectivity using the Arrow format, and 10 other languages that didn't even fit on the slide. We can also run in the web browser with WebAssembly. So you can go to this site, it's shell.duckdb.org. Of course, it's totally free. And you can pull data from all over the internet or your local files and join it all up, combine it all in your local browser. So very powerful. This also works in Pyodide. This is very recent, last couple of weeks. The Ibis folks were able to get Ibis running in Pyodide with DuckDB under the hood. So you can actually use DuckDB in Pyodide now for Python in the browser. It's also important for data science workflows, for data engineering workflows, just as a general Swiss Army knife tool, to be able to read and write formats of all kinds. So DuckDB can read and parse CSVs and JSON files into the correct columns. It can read and write Parquet. And we can also read Apache Iceberg. And you'll see we have that persistent .duckdb format. We do have our own on-disk format. And we've talked a lot about reading and writing our various data frame and array formats. We also work with dplyr. In addition, we also work with a lot of databases. So you can read and write to both MySQL, Postgres, and SQLite in a transactionally safe manner, which is pretty powerful. And we can do a lot of work also with files online. So you can read files from all over the internet. So every file on GitHub, you can read it with DuckDB. You can read and write to AWS S3, Google Cloud Storage, or Azure Blob Storage. So really a great Swiss Army knife to have to read and write data all over. We've talked a bit about our data formats as well in the ecosystem. We also can output TensorFlow and PyTorch tensors. We also fit with a lot of other libraries in the Python ecosystem. Data engineering is a great use case for DuckDB. We have a DBT adapter, and we work with multiple different orchestrators. We've talked about our dataframe APIs. Suba is a port of dplyr syntax into Python. And many visualization libraries are actually built on top of DuckDB as well. A lot of visualization operations are really data operations at their core, and DuckDB is an excellent fit for that. We also have a SQL Alchemy dialect, so you can do your schema migrations with SQL Alchemy. And that also allows you to use tools like JupySQL. So you can turn any cell in a Jupyter notebook into a SQL cell. So in summary, what were the 4 things I asked you to remember way back almost half an hour ago? Don't worry, I'll help you out. First things first, DuckDB is fast. It's table stakes. We use all the cores on your machine. We're vectorized. We take advantage of modern CPU's cache hierarchy to be as fast as possible, so you don't have to worry about it. But that's not enough. It's also got to be easy. There's no server to manage, because we're in process. It's a pip install away. But DuckDB is not an in-memory database. It's an in-process database. So we can not just solve your 16 gigabyte problems, we can solve those 2 terabyte problems that you have. And then we really want DuckDB to fit anywhere. Back and forth to data frames. Anywhere you're running Python, we think you can run DuckDB. So thank you very much for your time and attention, and I'd like to welcome you to the flock. All right, we have just a couple minutes left. If you have questions, feel free to grab a mic.
I have a question. Can DuckDB read files in place without converting into DuckDB format?
Yes, so it's a streaming engine, so that way whenever I read, I don't have to read the entire file for one, and I can read it in one format, convert to another. Gotcha. And you don't have to write it to disk before you work with it. You can even just instantiate DuckDB in memory mode if you'd like, and keep it all in memory.
All right. Okay, thank you. Yeah.
Great question. Yes.
Thank you for your talk. It was a great talk. I wanted to ask, what was your motivation to create this? Or like, what exact problem does it solve? Or what is its unique key selling point? What DuckDB can offer, what other tools cannot? Because you said it fits anywhere, has lots of features and everything, which is great. But I'm thinking more like, when should I use DuckDB, or what kind of problem does it solve which cannot be solved with other tools on the market?
Great question, thank you. So first of all, I certainly did not create it. I'll pass your thanks on to Hannes and Mark and the team at DuckDB Labs. But in general, I think there are certainly many ways to process data. I think there are many great tools out there. We're big fans of a lot of them, and a big part of our story is working really nicely together with them as well. So we do think there are other ways to do these types of things. I think for us, there wasn't really a powerful SQL engine that acted like a library for analytical tasks. So that was really a missing piece, was specifically on the SQL side. But also, just in general, this level of query optimization, this kind of performance, really, we think it's differentiated in general just for any kind of data processing if you're doing that kind of analytical workload. The key areas where it's not a perfect fit are really if you have high concurrency, you want to have multiple people doing it at once, or if you have really transactional workloads, like I really need to update things a lot. DuckDB has update support, but it's a lot more expensive to do than in SQLite. But thank you for the question. Sure.
Yeah, you said that one of the goals of DuckDB is that once you run out of memory, you're going to kind of degrade more gracefully. Sorry if I missed this, but can you say a few sentences about how you're doing that? So when you do run out of memory, how are you trying to ensure that the disk is used efficiently?
Sure, that's a great question. I will do my best to answer. I will say that Lorenz just did a presentation on this last week, and we also have a blog post out as well on the duckdb.org site. In general, we have a buffer pool where we can detect when we're close to running out of memory, and we can release certain blocks of memory and say this doesn't have to be in memory anymore, and the buffer manager can write it out to disk while it's processing if needed. So it's different for every algorithm, but in general, for group by and for joins, in many cases they're doing hashes. So we'll do a hash aggregate for our group by, and we'll do a hash join for our join most of the time. And what we'll do is our smaller hash tables, we'll go ahead and actually allow those to go to disk, and then start with a new hash table and fill that up. And then we'll have a subsequent step to then aggregate across all those hash tables that we've been working with. So there's a lot to it. Hopefully that helped a little bit, but you can come on up later if there's more questions.
Thank you.
Thanks for the question.
Hi, two quick questions. One was the little code snippet that you showed that references the Spark connector. It looked like it was coming from an experimental module.
Yes, it is.
When do you expect that to be in like a stable release? And then the second question is, you talked about persisting data frames, and like, what does that look like exactly? Like, is it easy to access those persisted data frames, and are they like sitting in a file in a directory or something like that? Thanks.
Great question. I don't have a real date for you on the experimental side for the Spark API, but feel free to send me a note and follow up with me, and I can ask the team. Thank you. As far as the persistence, the DuckDB file format takes its inspiration from SQLite, but instead of being a row-oriented format, it's column-oriented. But you actually have all of your tables in one file, and all the relationships between them in one file. So all your primary foreign keys, your views, your functions, your macros are all in that one file. So if you really wanted, you could email it around, but more importantly, you can just land it on object storage. So you can actually start to just have DuckDB files in places you might have had Parquet files in the past. Great question. Yes?
Thanks for the talk. Does DuckDB have any provisions to avoid data corruption, possibly even from like a power failure of a machine, or even just sudden ending of a process?
We have some. I think we want to do more in that space, but we do like a checksum process to make sure we don't have any corruption when we initialize. So there are some corruption checks in place. I do think that when you're in process, you're exactly right to ask about this. You're shouldering a lot of responsibility to be in someone's process, because if you crash, they crash. So you got to be really robust. DuckDB in the last several releases has deliberately added no more features and been entirely bug hunting for months now. And we're very close to our 1.0 release coming in weeks to months. And as a big part of that is really to get very, very robust. SQLite is an incredible example in this space, right? It is so robust, because they've built a ton of tests up over time and they test it rigorously. And we've taken that inspiration as well, so we take it seriously.
I guess, are there any instances where a partial write can make it so you can't read the entire database, or is it still recoverable?
That's a great question. I'm not sure I have that specific answer, but in general, things are pretty recoverable, I think. We have, we support ACID transactions. We have a write-ahead log, so I think there are ways to recover and roll back and things like that. So I'm betting it works most of the time, but happy to answer more detailed questions if you have them. Sure.
I have more experience with data frames than full databases, but one of the differences between the two was the things like the many-to-many intermediate tables and those sorts of things that you just don't have in Pandas data frames. So is there a benefit to setting up a DuckDB file that has that interconnected schema so that you can skip having to explicitly connect every disjointed thing in joins in every query, or just curious how that is involved with DuckDB.
That's a great question. So we're somewhat of a traditional database in that even though you specify those relationships, you still have to include the specific join in your query. So you do have to specify join just like you would in Pandas to specifically join. So we're not really doing anything automatic for you there. There are some tools that will do that. So if you have primary foreign keys, some like API generation tools will do auto joining, things of that nature, like some GraphQL endpoints will auto join based on keys and things like that. So there are cases where that can help, and you can define those primary key, foreign keys in DuckDB. So sometimes.
Thanks.
Thank you.
An additional question is, will DuckDB effectively use all of the computing resources, like spanning multiple threads, like doing distributed computing when querying?
So it will spawn multiple threads, but we are deliberately single node. So we don't do distributed processing, but we're really specialized in the multi-threaded case. We do Morsel-driven parallelism, so we parallelize at a very granular level, so we can really keep your cores really busy. So we keep them fully loaded.
Gotcha. Thank you.
Thank you for asking.
Are there any novel or special use cases that DuckDB has allowed that you've seen that come to mind that you'd like to talk about?
Sure. I think that's the creativity piece. So I'd also pose that question to the audience as well to be thinking about it. I think the in-browser use case is very innovative. Another one I've seen is kind of running it at the edge. You can run this on a Raspberry Pi. You can run it on your phone. Or you can run it on all of your servers to do things like pre-aggregate your logs before you send them to a central server and kind of use that spare compute you have on your existing servers rather than have to pay for centralized compute. So there's a lot of advantages there. You can do a lot of on-the-fly calculations. So if you're in an orchestrator environment doing a data pipeline, you could just do the processing right in DuckDB rather than have another underlying engine underneath your orchestrator. The orchestrator could do the compute as well. So it really fits in a lot of places. But those are a couple off the top of my head. Thank you for the question. All right, thank you for letting me eat into your break time. Thank you for the great questions. Have a good conference.